Good morning, fourth grade online learners. Welcome to Mr. Monzo's class, February 8th, 2021, where we are going to learn about heating and cooling matter. Very good topic because it's freezing out there. It's cold. And I visited my daughter at college yesterday, and it was even colder at Slippery Rock, Pennsylvania. I told her I've never been that cold in my life, and the wind was blowing. But maybe I'm just getting old. Okay, so we're going to read from the book a little bit, and we hope you have some energy. Daniel, what do you need?
At my house, the snow is like frozen. Oh yeah. And it's like solid.
Yeah, the snow is like you can almost walk on it right now without sinking into it. It's so cold. Thank you for sharing that, Daniel Rupp. Okay, um, and we did comment a little bit about the Super Bowl, and we're talking about energy in fifth grade, and some of us may be lacking energy today if we stayed up and watched it. And I was just telling the fourth grade class that it was a great game, and talking about Patrick Mahomes, how he was hurt, his big toe was hurt, and you don't realize how much you rely on your big toe until it's hurt. And Emma Ginsberg also shared with us she has an injury to her foot, and it's hard to do anything when you're injured. So we hope Emma gets better and Patrick Mahomes gets better, and if you're a Kansas City Chief, we have better results next year. So, with all that said, welcome back. The longest day of the year, the day after the Super Bowl. Heating and cooling matter is what we're talking about. And this is on page E44. And remember, we have journal entries Tuesday, Wednesday, Thursday. Today we just read from the book. Friday's our quiz. And next Monday, we will not be in school, so there will not be any work next Monday. Okay, teachers will be here. Actually, guys, I'm making a video. Actually, I will be learning about a new science program we're going to be getting. It has a lot more online activities and maybe even some hands-on activities. We've been waiting a long time for this. So I'm not going to answer questions right now, guys, because remember I'm making a video, so we sit still. Thank you. More to come on that. I don't know if that'll be this year or next year, but we do have some new science coming your way. Not our good old faithful that was copywritten in 2007. Just saying. Heating and cooling matter on E44. Heating and cooling matter changes the motion of its particles and the spaces between them. Suppose you have a small box and the bottom is packed with marbles. You shake the box gently. The marbles might jiggle, but they don't move and spread out because they are tightly packed in the box. These marbles are like particles in a solid. When the marbles move, they have energy of motion, even if it is just a small amount. You could say that they have very little thermal energy. Thermal energy is the total energy of the particles of matter. It is related to the energy of moving particles. The particles of a solid have very little energy and motion. So if it's hot, those particles are moving around like crazy. If it's cold, they definitely slow down. The particles of liquid iron are farther apart than the particles of iron in the solid beam. This change of state occurs because the thermal energy of the iron has been increased. Okay, next page. We keep talking about this iron. It's no longer boiling hot. It is a solid metal beam now. If you shake the box harder, you could add more energy to the marbles. The marbles would break out of their arrangement on the bottom of the box and move further and faster. This is also true of particles of matter. If you add more energy to matter, its particles move faster and farther apart. Thermal energy can be added to matter. It can also be taken away from matter. You cannot see thermal energy, but you can feel it as heat. Heat is the flow of thermal energy from a warmer area to a cooler area. When you add heat to matter, its thermal energy increases. The particles of matter move faster and farther apart. When you cool matter, you remove thermal energy. The particles of matter slow down and move closer together. When the metal jar lid shown is heated by hot water, its particles move faster and farther apart. The lid expands or gets larger and loosens from the jar. Cooling the lid would cause particles to move more slowly and closer together. The lid would contract and get tighter. So if you're ever having a hard time opening a jar, put it under some hot water for a while. Don't burn your hand, but put it underneath some hot water, and then the particles, the molecules, spread out, and it's easier to open it than if it was cold. How many of you people already knew that? About 3 or 4 of us. Okay. All right, next page. We have a hot air balloon, guys, and I had the pleasure of going up in a hot air balloon many years ago, and it was kind of neat. Thank goodness it was tied off to the ground because we didn't go. We went about 100 feet in the air, and that was it. Nathan.
What happens if the balloon pops?
If the balloon pops, you go to the ground very fast. If that balloon pops, gravity is not your friend. But it doesn't actually pop. What's going to happen is if you slow down the heat, it'll come to the ground. But if the heat goes out all the way, you're coming to the ground very fast. Sebastian, if that guy turns off the heat, if he turns it off all the way, he'll come straight to the ground. If he slowly decreases the heat, he'll come down very slowly. If he turns up all the way, it's gonna go very high. All right, 4th grade. We've been very well behaved, but we're starting to get a little silly, and it's unfortunate because we're making a video right now. Wait until this is over, then we can talk. Temperature. On a snowy night, the air outside is much colder than the air inside your house. How much colder? You can find out by measuring the air temperature. Temperature is a measure of how hot or cold matter is. It also describes how fast the particles of matter are moving. Particles of matter move slower at slower temperatures, or at lower temperatures. Particles of matter are faster at higher temperatures. A thermometer is a tool used to measure temperature. Some thermometers are made of a tube filled with liquid. When the air around the tube is heated, the liquid expands and rises in the tube. When the air is cold, the liquid contracts and falls in the tube. Thermometers measure I almost said mercury, that's what's inside a thermometer. Thermometers measure temperature in units called degrees. Scientists and people in other countries use the Celsius scale. In the United States, we use Fahrenheit. Okay, and that's named after the people that discovered that type of measurement. Let me do a time check here, and yes, we're approaching 8 minutes, so we're going to stop reading from the book today and say we'll read some more tomorrow about temperature and the energy of moving particles. No journal entry today. Stay warm in your house because that's kind of what we're talking about, temperature. Stay warm. If you go outside, don't stay out there long. It's cold. And we will see you tomorrow for a continued discussion. All right, all you online learners and all your older brothers and younger brothers and sisters, say hello to everybody, and we will see you tomorrow. Bye-bye.